Alright, hello, welcome everybody who happens to join during this recording or before, after, or whatnot. You already know who this is. It's your boy Laz. And, we're going to be going over the laboratory software suite that I posted a vlog about. So, just covering a little bit of a background and whatnot for what we're going to be getting into for early this morning is we're going to be checking out Geosystems, and it's a laboratory suite that helps report laboratory results to clients and whatnot, as well as engineers, so they know primarily the properties of soils and things like that. So before we really dig into this, nothing is scripted. So we're just going, the way how things are happening is however that they're happening. If you happen to join live, even better. But even if not, I don't think I have any plans of editing any of these videos unless I need to take an extended break or something like that. But other than that, I'm sure this is just going to be posted in its entirety as is. So, yeah. Um, I'm hoping everything's going to work, because once again, I haven't tested any of this out. But enough of me yammering, right? Let's get to it. Also, this might be a little loud, too, so you might want to cover your ears. Because I don't really have any of my sounds or anything adjusted for this very fun experience. So the thing I don't know when it comes to Geosystems is I don't know if this is going to run right out of the box. This has always required licensing, and the thing is with later versions of Geosystems, the licensing is handled through a file that when you install, it will look at the file, realize that it belongs where it belongs, and then it's activated right off the bat. I don't know about this older version, so this is why at least the Geosystems portion could be a big flop here. But we'll see. So like I said, we're just gonna go as we go here. So I need to insert a floppy disk, and I think we're going to start with the data manager. Hold on, actually, let me double check that real quick. Data manager classification module. Yeah, no, let's check out the data manager. At least I think it's the data manager. SG envelopes. Yeah, I don't know. Let's see, because I'm hoping I'm not pulling up the other one, which, yes, let me see about choosing real quick just to really make sure here. Windows XP. Okay, yeah, no. Yeah, all right. I just wanted to make sure. All right. So, the way how Geosystems works is everything is a separate package when you purchase it. So if you wanted to do sieve analysis, and I know I'm going to be talking about a whole bunch of things that probably the most common Joe doesn't know unless you're in the engineering, geotechnical engineering specifically. so if you wanted a proctor and like sieve analysis, you had to buy those packages separately. This program wouldn't come with everything. So the data manager overall is like your core system of what you really need and whatnot for like project creation and things like that. So I think this is where we really need to start, and then we're just going to kind of go from there. The big end goal for this video, for what I'm going to try to do, or for what we're going to try to accomplish, is try to input an Atterberg test and see if it plots and does everything the way it needs to, well, the way how it should do it. So we'll start with this one. Let's see here. See how this setup process goes. Because the entire time I've worked with this program, I've never installed Geosystem. Well, I guess Geosystem. I always say Geosystems because it has all kinds of different modules and things that you can do, but technically there's no S at the end. And it's not spelled like, well, at least I hope this will work. Because the VM hard drive is not doing too much spinning right now. I only picked Windows XP because it's the last instance of Windows operating systems that can still support DOS-based systems. I mean, granted, if it's like 16-bit, it's probably not going to work. Honestly, if you wanted to run like a 16-bit, I think you had to use like Windows 98 or something. I think anything that was before NT. Ooh, this is not really going anywhere. Ooh, this could be turning into a big flop here, huh? It's not responding. Hold on, I'm being patient. No, hold on, it's trying. Ooh, this is, I don't think this is working right now. Wow, it has loaded up a lot of stuff. And nothing is running at all. Yikes. Oh, a VM. Boy, howdy, the power of a VM. And nothing going on, which is good. Oop, I mean to bump into the microphone. Well, that's not great. I think we're going to have to end these tasks. Ooh, or is it not going to let me to? Oh, there we go. Had to pick the right one. I guess we better keep that open. Yikes, that's horrible. But I'm wondering if it's this high because I'm streaming and also doing a screen capture of this too. So, well, at least the main machine's doing fine. That I'm not worried about, but yeah. Weird for this. So I guess we could try again. Actually, I'm pretty sure this is just going to be like a standard. Actually, will it open up Notepad? Yeah, it does right off the. Let's see. That. Launch things first set, zero values. Setup. So I'm wondering something here. Just wondering something here. I'm wondering if this is going to change. Yeah, because man, that thing is just very interesting for the page file usage. But I'm wondering if it's that the VM's only getting slammed because of wow, the box tray. Are you serious? I don't even see it open right now. Oh boy, that's Nope, it died down. That's the thing, is like I feel like if I get rid of that, it's going to probably make the system unstable. But man, it's using all my CPU. Let's try to end the process. Nope, I don't think it's going to let me do it. Nah, it ain't going to let me do it. Probably because it's part of the actual system itself. But I don't think that's what's going to slow it down, though. I don't think that would. I know that is really eating a lot of power, the processing speed, and that could be an issue why this can't go. So I think what I'm going to do, we'll just pause. Okay, everybody, I'm back. Sorry for that little break. It seemed like it had an issue while it was recording, but the thing is now it seems to be running just fine for whatever weird reason. I mean, I get it. You know, it takes a lot of processing power, but I don't know why everything was all alkylated to, oh, but maybe it finally closed whatever that thing was and it couldn't because it was running. I don't know. I don't know what's going on. But anyways, we're going to run this installer now and whatnot. You know, I mean, that's the power of VMs. So yeah, that seems good. Are there any other modules you wish to install? Kind of, yeah, actually. But I'm just going to say no for right now. Let's just see what the bare bone basics of what Geosystems for Windows is, and then we'll kind of go from there. Oh, it doesn't do a desktop shortcut. It creates a start menu shortcut, but create me a shortcut. Alright, let's see. This will work. Alright, cool. Alright, so All right, so, programs license for Nadarcy and Associates. That's the company that we were before, but now we're something different. So let's see here. Click here for information on data. I want to click here for the text of Geosystem license agreement. Let's see. To begin, select an option from the menu to show the top of the screen. Okay, yeah, it just opens up the help file. Ugh. That's in the most worst place where you can have that. Okay, cool. So I think we do need to install some modules and whatnot. Good Lord, this is huge. On the current screen. Okay, yeah, so this just has the demo and whatnot. File new, select open. Okay, yeah, so it does the same thing. So, I don't know. Let's just start a new project. Let's do LAS. Let's enter into project data. I think we got to install some modules. Data summary, export. The script is out of range. Oh man, we can do envelope printing, but I have printer errors. That's not cool. What the hell kind of... Yeah, that's not a real directory. Okay, yeah, there you go. Why did it do that? Oh, what is going on here? Did it seriously do what I think it did? Okay, yeah, no, it created that because that's what Geosystems does. Projects go in folders, even though that's what you pull up, but it should just why did it do all that? Can I delete that? Well, that's really weird. I don't know why it did that, but it did. Okay, so I think we're going to install some modules. So, which totally makes sense because it's like I said. I don't think the modules can run on their own without your actual data manager, which, that's so you can pick the module to use for the testing that you're going to do. All right, take a sip of tea. Well, that's good. I'm glad everything, well, I hope everything's working fine with the stream and whatnot. I mean, we're still, yeah, we're still going. Still going, no problem. Okay, yeah, so I guess we're just gonna have to install some modules here. So let's see here. If we go to floppy, swell, slope, grain size. So I think we're going to select the classification module. And the classification module should have hopefully the ability to put in Atterbergs, but it could be that it only, that it actually classifies the soil. So I don't know, let's see. It's going to kind of suck if I have to install everything all at the same time, because I was planning on doing everything separately, but no. Weird that I did that. Okay, so let's see here, because I really want to try to get, oof. Yeah, I think that's only going to classify it. I think that's only going to classify it. So is this thing still going to work? Hey, look, maybe now it'll work properly. What if I say OK? Select close. Okay, yeah, so here we go. Wow, this is way different than what the... Holy crap. Yeah, this is way different. Let's see here. Alright, what if I hit new? I wonder if this is only going to do just I think this is only going to do classifications. I feel like this is only going to do classifications, but let's find out. So let's say our sample is going to be B1. We'll say, wait, can that really get typed anywhere? Are you serious? No way. Like, you can select. Whoa, this is like old school. Like, that's not how that's supposed to go. Wow. That's wild. Okay, anyways, 0 to 2 feet. We'll just say that. I mean, let's say our soil description will be gray, clay, sand. And we'll do AASHTO classification. Wow, so this is actually like you put in all the individual components. Okay, yeah, so this does only do just those classifications. Okay. We're going to have to add more modules. Which I'm not surprised. I'm not surprised at all. I'm not surprised. This is why we're having fun. Okay, I don't think... Actually, no. I'll leave this one open just to be safe. I know, I thought I was going to do full screen mode, but I mean, I'm going to be swapping around floppy disks. So... Alright, so we got the data management classification module, grain size and slope stability. See, the grain size, I don't think it's going to let you put in an Atterberg. I wonder if they never purchased the Atterberg module. Is what I'm really beginning to wonder now. Because you really need an Atterberg to help classify things. But no. Okay. I know. I want to put in an Atterberg. God damn it. This sucks. Wow, this can't scroll. This can't do nothing. Alright, so let's open the project. We'll go back to LAS again. So now I think if we go to here, now we can do a grain size distribution. Yeah, this is way different than what I'm used to. See, you can put in your Atterberg values here, but you know, it's calculating an Atterberg is what I really wanted to happen, and it's not. Oh man, your different sieve sets. Oh cool, man, comes with C33 and 147. Was it M29? I can't remember whichever sieve set. Or we can create our own, which, you know, we have our own there at the office and whatnot. See, this sucks. I really didn't want to cover grain sizes yet. But I have a feeling we can't do Atterberg, which I already have a pre-calculated Atterberg, so I can fill out the PL, the LL, and the PI. But it'd be cool if the program could do that and then implement it. But I have a feeling they never purchased that module back in the day, is what I'm thinking, which kind of makes sense because, I mean, you could hand plot your own Atterbergs and it's not difficult, but I mean, now this day and age, people will laugh at you, if you had to hand plot it. Use your computer. Yeah, wow, these elements are broken like hell, which could be because, we're running on a very newer operating system, because I think this was meant for Windows 98, 95, 98, maybe NT, tip top NT. Oh man, I know that sucks. Oh, I know. That sucks. I wanted to do an Atterberg, but I may not be able to do an Atterberg on this program because we got the classification module. Hell, wait a minute. There's Atterberg limits. I was about ready to say, I mean, come on. You need Atterberg limits. Okay, so let's install this module then. I should have just went to there instead of me just kind of picking around, picking and choosing or whatever and whatnot, but I mean, it is what it is. Okay, anyways, let me take another sip of tea. Well, at least this is already pre-activated or pre-licensed things, because that was the only thing I wasn't too sure about for the Geosystems and whatnot. So cool, this is great. Okay, so I do have Atterberg. I'd hope so. I mean, for all the geotech stuff, whoops. I mean, come on. You are upgrading from a DOS version of limits. Yes. Uh-oh. Check the box at the left if you would like Geosystems for Windows to utilize the TER database created. No. No. Huh, that's weird. That's really weird it would ask for that. So, okay, so now, almost hit search. Now we should be able to do some Atterbergs. Yeah, now we can double click. There we go, baby. Let's double click. Neat. Okay, so this window is kind of big. Can I tab down to... I don't think this is enter-friendly. Grain size distribution. So there's something I'm missing boxes. It's probably because of the size of this thing. Oh, good lord. I wonder if I can... Yeah, this isn't showing. God damn it. Go away. This isn't showing everything that I really need to do everything. Hold on. Let's see. Maybe that'll work better. Ooh, okay, hold on. This might... Oh, yikes. Hold on. Let's see if I do. No, I can't access the bottom. Yeah, I can't access that bottom there. It's too far down. 46. Oh man, I really don't want to do that. And that's weird that it's like set up like that. Ooh, wait. Oof, yeah, this is probably not going to work neither. Because of the screen dimensions and whatnot. As my cat picks at the door because she wants in and I can't let her in. Because obviously I'm doing things. Yep, poor Daisy. Okay, See, now here's everything right there that I'm going to need, but this is the crappy part, is the screen resolution. How's this supposed to work? Ah, man, this sucks. I know, because I don't want to do it. I don't want to scroll around like that. I really don't want to, but I think... Oops, didn't mean to bump into the... Well, that didn't work. Resize guest display. What's scale mode? Switch to scale mode. You can switch back to window mode by pressing Control Host C. Oh, Jesus Christ. I mean, you can see everything now. Oh, good God, this thing is stretched out. And it's like weird. I don't know, let's just save and exit. Oh God, I mean that might have fixed the problem though. At least for everything to show up. Hey, look, everything shows up. Okay, yeah, I mean it's stretched out, but hey, it works. That works. It's better than nothing for sure. At least now we can see everything. There we go. Okay, cool. Yeah, so here's everything that we need for Atterberg limits. So let me talk about Atterberg limits here, because you know it's not a fun last time unless he adds boring exposition to his everyday life. So Atterberg limits. The idea of this test is to determine your liquid limit and your plastic limit. A lot of these tests are named after people's last name. This guy's last name was Atterberg, and he helped develop this test to determine, like I said, liquid limit, plastic limits, so you can figure out your plastic index. And the whole idea of this test is to help classify your sample better. So this is for like clays and silts. So the idea of an Atterberg test is if you live in an area that has clays or silts, if you ever played with clay in general, you can roll it. You can roll it and mold it and do all this other stuff and whatnot. So the idea with Atterberg limits is for determining these values is besides help classifying it, which is huge for the engineers that have to figure out, hey, how are we going to you know, are we going to build on it? Are we going to use it? Does this meet certain properties for whatever the intended use is going to be? And I know I'm very vague about it because there's so many different uses for soil. You know, what's suitable and what's not suitable is all based on project criteria. So I can't say if something is suitable or not suitable, because something that might be not suitable for one site could be suitable for another site. So the thing here is, and here we have a handy dandy classification table to help place it where it needs to go, which I'm pretty sure as I fill in the data, I'm hoping it will plot where it's going to be on there. But so the thing is that the plastic limit of a soil is where you're able to roll the soil down to like a 3 millimeter diameter. So almost like a little log that you would roll down to a 3 millimeter diameter, and you keep doing that until it becomes brittle and falls apart. Because everything here is all based on a moisture content. So before I go any further, let me talk about moisture contents. So anything that is a moisture content for soils and aggregates, which aggregates is another fancy term for rock, is you get your material at whatever your wet state is with the tare that you're going to use, and a tare is just a container that's going to hold your sample that is oven safe. So you get your wet sample in there, you put it in the tare, you put it in your oven. Your oven's set at a temperature, at least for right now, the specification says 230 plus or minus 9 degrees Fahrenheit, or 110 plus or minus 5 degrees Celsius for everybody else. And you let it sit in there until it stabilizes. And depending on the method, some say 12 hours, some say 15 hours. And then sometimes, if it looks like it's stabilized, if you can do 2 successive weigh-ins where it doesn't change, then it's dry, is another way to do it. And then you weigh it again once when it's dry. So this is your dry sample plus tare. So that's why I have D plus T. And then you have tare, which that's your actual weight of your tare. And then this is Atterberg specific, liquid limit specific, but that's how moisture contents are, and this is all based on moisture content. So as I'm going to be filling this out, what I'm hoping what will happen is that we'll see data pre-populating here, because this will determine our moisture content. So right here should tell us what our moisture content is for each one of our points for our liquid limit as well as our plastic limit down here. And then from that, it should be able to plot here on the table to determine where it should be classified, give or take. So the idea is that when it comes to clays and silts, it really needs to, if you want the rigidity of it to be maintained, I guess is the best way to put that, is it needs to stay within a specific moisture content. And that's what this test helps determine is, at its driest limit, because when you do your plastic limits, you keep doing it until it starts crumbling apart, and then you get that moisture content. And that's going to determine your plastic limit, which is PL here. And, for this, it's just an average of all of your moisture contents, whatever that's going to be. And then here for your liquid limit, it's the state when your clays and or silts go to an actual liquid state, which can be deceiving unless you actually see the test in action. Because it's not like a liquid state is where you can pour the soil, or you can pour it into a cup or anything. So the term's a little bit deceiving, but if you work with the material like how I do, then you would have a better idea. And I mean, I'm probably not explaining it. I know I can explain this better. Is all I can say. I know for a fact I can explain this better from the years of working in the lab and doing materials and whatnot. But I don't want this to be 20 minutes of exposition. I'm pretty sure you guys just want to see this work. So let's put in values. So in front of me, that you guys can't see, I have a proficiency sample I did way back in the day, and an Atterberg proficiency sample that I'm just going to put in, and I'm just going to check to see if everything's just going to be working however that it is. So with the general sample information, as we can see here, we got water content, which usually means what is your natural moisture content. Now that's usually just natural moisture in the value in the form of a percent. Your USCS is one way to classify the soil. What is that? It's Unified Standard Classification System, USCS. I think that's what it's called. I could be very, very wrong about that. And then AASHTO is the, I can't remember the acronym, but it's pretty much American Roadway Specifications is what AASHTO is. And then testing remarks is exactly what it is. You as a technician, what do you want to indicate? Did something go wrong? Did something go right? Did you find a new spiritual meaning in life or something? You put it here in the testing remarks. That's the thing. It's just notes. Okay, so I know for the most newer versions, I don't think this is tab. Okay, this one doesn't seem to be tab friendly. So this is probably going to be enter friendly is what I'm assuming. So let's put in our liquid limit values. So let's see here. So I got 28.28. Oh, good, it is enter friendly. 25.70, which makes sense because the newer one is the same way. Whoop, that's not an enter. All right, and then blows is 32. Let me just enter everything in because I want to. I'm gonna come back and explain what blows are here. 27. Hey, look at it. Now it's plotting. That's perfect. It's perfect. It better. I mean, it is lab software. 2108, and then we got 20 blows. Okay, perfect. Okay, so let me kind of explain number of blows here. So technically, to do a liquid limit, you have to use this thing called a liquid limit device, and it kind of almost looks like this icon here. Like this is a side view of what a liquid limit device is. So with a liquid limit and device, it's a very there's set dimensions. You have to calibrate, you have to check, you got to make sure everything is within and that it's it's doing it meets the specification. Let's put it simple. It's just got to meet the specification of the test method. So it's very specific for the kind of device that you use and the materials that make up that device. So the thing is when you do this test, you're going to count how many blows it takes for the opening to close. And the opening is so when you do this test, you're going to make a groove within your clay material within the cup that you're going to put the material in. And when you do that, when that groove closes by, well, at least now the specification is 3/4 of an inch of a close of a gap of not a gap of a closing within the groove that you made within your liquid limit device. Once you get a 3/4 of an inch closing, then that material you're going to scoop out with a metal spatula, and then that you're going to put in your tare and then weigh it, and then that's going to be your moisture content. So that's what these are. So at 32 blows, so this device running 32 times, it it met that criteria of the groove closing in any part of that groove there closed at 3/4 of an inch. That moisture was 41.4% water content, which is your moisture content. That's all this is calculating, is how much moisture was it at this point. So the whole test method here is that you're trying to determine a dry point, a medium point, so kind of a wetter point, and then your wettest point. And the thing is that out of all these points here, you want to try to have it where it's going to close that gap between 25 to 35 blows, which is your first point, so that's going to be your driest point. Your medium point, which will be wetter, as we can see here, we have 42.1 and it closed at 27 blows. And for that, you got to make sure that your blow counts are between 20 to 30 blows. So as you're seeing here, a lot of it's kind of crossing one of another here. And then for your wettest point, and as we can see here, as it climbs, so this one has 45.2% moisture content. That one, as you do it, you want to make sure that once when you get a closing on it, it has to be between 15 to 25 blows. Now, if we look at this table here, this very, very hard to read table, so the whole idea here, and you could probably see very... God, this is horrible to read. This is horrible to read. Anyway, so as you can see down here, this is your number of blows. So you have your number of blows down here, and this here is your actual moisture content. Your number of blows always, at least for your table, always stays in the same orientation. That almost never changes on your table. It's usually your moisture content. Moisture contents can vary from material to material, okay? So, you can have something called a fatty clay, and, you can have a fatty clay that could be over 100% moisture when you do this test. Just saying, in general, you can have that. So it's not unheard of to have, if it's either a fatty clay or something called peat, which that's pretty much decayed plant matter. So, dead plants that have decayed and have compacted, and those can hold... Those are usually a dead giveaway because those can always hold over 100% moisture by mass. So that's always a dead giveaway, and that's organic-like material, as it's called in the industry. If somebody says, hey, I want an organic content, it's usually to determine, hey, how much organic matter is in there, which is usually, roots, dead plant life, and things like that, because that can really, really mess up soils, especially if you're trying to build on it, because it can settle and move, and things can grow in it, and if things grow in it, you can have a bigger problem. But anyways, I'm going down a rabbit hole again. So the whole idea of this test, so you have this green line here. So this is your 25 line. So the way how this test works is you have your 3 points here. So we got our 1, 2, and 3. Yeah, we got our 1, 2, and 3. It's so hard to see. Obviously this is a 2. This looks like a 2, but it's hard to see which one is 1 and 3. But fortunately, with the moisture contents on the side, that's also hard to read. I can tell what everything is. I'm sure if this was a lower resolution screen, we probably would see this a lot better. But since this is a high resolution screen, I think that's why everything, simply put, looks like shit. Excuse me. So the idea of doing a liquid limit test is what is your reading at 25? Now, as I was covering over blows here, and I know I can already hear everybody yawning, and probably you're clicking off the video or just wondering like, man, Laz, I don't know how in the world you could do this, but this is what I do. I mean, except for the explaining part, because, everybody's educated, well, hopefully, and if not, then, well, I educate them. Anyways, so your 25 mark is what is considered your liquid limit. It doesn't matter on what type of material it is or whatever it is. When you do the liquid limit test, it is what is your moisture content at 25. And when you do what's called a 3-point liquid limit, which I'd say most people typically do this. And I only say typically because technically you have other test methods. So, there's another test method from ASTM that indicates that you can do a 1 point, which that's why you have this 1 point checkbox here, where it'll more than likely gray everything else out and then you just do 1 point. But when you do 1 point, it has to be at 25. So it has to be dead nuts 25 when you do your test and then collect your moisture content, which isn't hard if you're experienced in doing it, but I usually like the variation instead of just getting 25, because here was 27, I was at 42.1%. So here it's saying 25 is at 43% moisture, and it rounds to the whole number too, by the way, for final results. So if we try to keep that in mind, you can see the variation where, like if I got this at 25 here, then this would be, 42% if all these values were the same thing. I myself, and usually most people in the industry, like a 3-point Atterberg because of that variation. Because, I mean, if we do... Is it going to work? No. Really? It's not going to work at all? I just want a calculator. Nope, no calculator. Seriously? My macro button ain't going to work? Good Lord. Okay, so let's bust out this very old calculator. So, I know, everybody's getting even more excited. Here we go. All right, let me take another sip of tea. I'm just getting warmed up. It's probably there's nobody on the stream too. It probably doesn't even take 5 minutes, or even if they're on the stream, I'll bet they're asleep at their at their computer device. Okay, so I like this because, let's say we get an average of these three, just in general. So here we got 41.4 plus 42.1 plus 45.2 divided by 3. So as you can see, even with the average, we're pretty much at 43. But that's not the idea of this. But doing these three made it where even if somebody's doubting where this is going to be classified as, people can double and triple check, seeing like, okay, you know what, these are all pretty close to each other. Okay, 43 makes sense, which, I mean, even you can look at the table to see, because, if you're not experienced doing this, if you're not experienced doing this, so let's say I had like 24. Now, have you seen how much that line has moved? And look at the differences now for where the points are, because these are exactly where our points are, but look where that line is. So we still have 43. We still do have a 43. So it didn't change all that much, even with having all three of these. But the thing for this test method here is where the line goes, it's a best fit. So it's not about it connecting to the points itself, because otherwise it would go boom, boom, then boom, which then that would make that more, if it did do connection, that'd be more close in line to a 40, I think that says 41.5, about there. I don't know. You can't read it because because shit is just so pixelated. You can't read it. But this test method set up where it's a best fit line, and then wherever that line is, where it makes contact with 25, wherever that is with moisture, whatever that is with the moisture content is your liquid limit. So, I mean, maybe that wasn't like the best example to show, but this was actually a pretty good example showing a best fit line, how that would work there. So it's not about it connecting, it's about it, where does it best fit in between these 3 points, and then you draw a straight line where it would intersect all these points and whatnot. What was that, 27? There we go. Yeah, so technically this line doesn't really connect at all, which, I mean, you can't really see because of the graphics, but that's just how that is. Okay, so I think I talked enough about that. So now that's your liquid limit portion of your test, which that's really the I don't want to say the meat and potatoes, but that's like the most complicated part of an Atterberg test, is doing your liquid limits. Now let's cover our plastic limits. Now, I just want to cover here, just in case, 21.50. Just in case somebody's going to be screaming at me here and whatnot. Now, for anybody that's an engineer that might happen to cross this video somehow, some way, some shape, some form. So the thing here is that at the current moment, because technically this was ran for our Florida Department of Transportation proficiency sample that I did like 5-ish years ago, I'd say, give or take. It's a give or take on that. Almost 5 years ago when I ran this test. And the thing is that, so for our local DOT, so they follow AASHTO method, and way back in the day, so where this program fits in. So when you do AASHTO method Atterberg limits, you do the 3. No matter what, you do the 3. It's only ASTM where you have an option if you want to do a 3-point or a 1-point. AASHTO, you do 3 points. You got to do 3 points, following the same criteria that I explained before. So plastic limits, the way how that was done for AASHTO is that you would run 4 points. If you did it for ASTM, you only had to run 2 points. And it was all based on your material size. So the only reason why there's only 1 here is because a few years ago the AASHTO method changed for plastic limits, indicating, well, before I get to that, let me cover how it was worded in the past. So the way how it was worded to do plastic limits in the past for AASHTO method was you got an 8-gram sample from your clay or your silt, whatever that you're testing, and then you break that down into 1.5 to 2-gram balls, and then you do 4 tests. So 2, 4, 6, 8. So you pretty much use your whole sample, and then boom, you have your 4 tears. They'll have your 8 grams. So it's only been a few years ago that the spec has changed, that it says you were to grab a 10-gram sample instead of an 8-gram sample. But where things get conflicting is it says you're going to use 4 tears, but you're still going to do 1.5 to 2-gram samples. So then technically by the end, you're going to have a 1.5 to 2-gram ball out of the 4 samples. So for our local DOT, how we've been told to do it, and this is, and this is primarily for their projects, and we really only do it for their projects and whatnot. So what they've indicated is we want you to get the 10-gram sample. You'll still do it like that, but you can just put all of your material in 1 tear and then weigh it and then do it. So that's why this one only has 1 tear for that, is because of that that convoluted change to the specification that occurred. So yeah, in case for those, if another lab person or an engineer from like a different state or country or something is like, wait, what the hell, Laz? Like, you don't know what you're doing. Well, that's the only reason why. So here in Florida, we can deviate for that for our Department of Transportation. That's how they would prefer it to be done. Or you can do 5 tears, which the issue is that most programs like this one only allows up to 4. So that's why they indicated you can do 1 or you can do 5, but you buy any off-the-shelf program, it ain't doing that. So it's something you would have to make in-house if you wanted to do 5 separate tears, doing the 1.5 to 2-gram samples. All right, and then here we are. So when you have your liquid limits and your plastic limits all entered in, it's going to plot on this table here, and then that's going to indicate what group classification that's going to be in and whatnot. Usually for I don't want to cover too deep into this because classifications can get really, really convoluted here. So this helps classify it within the group that it needs to be within. So let me give you the general synopsis of classifying samples. And the thing is that if you were to classify a soil, let me step back a bit. There's 2 ways that you can. So you can do visual descriptions in classification visually, which that takes years of experience, handling the material, stratifying material, which stratifying is a fancy word for just examine, because you're examining the strata of the soil. That's what I call stratification. So all the different layers and stuff. Whoops, keep bumping into the microphone. I'm sorry, everybody. Maybe I'm nervous or something. Maybe I just don't know what I'm doing. Anyways, so you can do it like that. And usually if you do visual classifications, you fine tune or you hone your skills better with lab testing itself. So if you think one thing, you'll assign a test, and then it'll give you the definitive results, and then that's how you can get better. Some engineers like to call it calibrating your skills, which I think is the best way of putting that and whatnot. Because you might think and this is how detailed this can get when it comes to soil classification. Because you can have an elastic silt, but depending on where it falls on, well, this table, if an Atterberg limit's performed, it also depends on the wash, and the grain size is going to help determine if that is an elastic silt or a lean clay or a fatty clay. Because it could fall anywhere in that group. But it's with the actual laboratory testing side is where you can definitively classify it. So that's one way of doing it. The second way is through, as I kind of covered a little bit, the actual testing aspect. So the thing is, when it comes to classifying a soil, like the bare bone biscuits, wow, the bare bone basics of classifying soils overall is you need a wash done on it, and a wash is exactly what it sounds like. It's washing soil. There's so many different ways and methods that you can wash soil. It mostly depends if you're going to use like either basic dish soap, or if you're going to use chemical means, which is sodium hexametaphosphate, to clean your soil. And I mean, washing it is exactly as you think it is. It's running water over a sieve, and you're washing all the fine particles through. That's one way to, well, that's one part of classifying your sample. The bare bone basic to classify a sample. So if you want to say if there is silts or clays or anything of that type, you have to do a wash, basically. The other thing is doing a sieve analysis. In a sieve analysis, it can either be after washing it, you can do a sieve analysis, which that's what this button's here, which I think this button's only here because I installed the module. But you see, but we can't classify it. As you can see, this is grayed out because it needs at least a wash. So, when it comes to either a grain size analysis or just a regular sieve analysis, it's to determine how much material is actually sand. When it comes to this USCS, or the Unified Classification System, is what it's basically called. It's how much material is passed through your number 4 and whatnot, which I'm wondering. 5 tests per page. Moisture resistant plasticity. Okay. Yeah, I think that's fine. I wonder. Whoops. Okay, yeah, no, but I think it saved everything. So if we go up to here real quick. So when it comes to a unified classification system, all it really wants to know is how much rock is in it. This is the bare bone basics. How much rock was in it? When it comes to 3-inch or 75 millimeter rock, so the idea is anything that is rock that is bigger than 3 inches is considered cobbles or boulders at that point. So does it have cobbles or boulders in the sample? So do you have anything retained on your 3-inch sieve? And most of the time, at least for what we deal with here, it's usually no. As well as how much did you have retained on your number 4 sieve, which your number 4 sieve is not 0.75 millimeters. 4.25 millimeter openings is what a number 4 sieve is. So think about that. So the actual size openings on this sieve is I think it's either 4.25 or 4.5 millimeter openings. So it's not that big. So anything retained on that is considered rock. rock aggregate. However, at least when it's soils, it's considered rock. If it's processed rocks, they like calling that aggregates. Those are those other terms. I know, man. I'm doing a great job boring everybody. It's my favorite thing to do. What can I say? So you have to have a number for that. So that's another part of your sieve analysis, or your grain size analysis, as you would put it, and then how much was passing your number 200 sieve. So now, first off, these numbered sieves it's a U.S. standard number, is what that is. So technically, when it comes to sieve sizes that are, I'm trying to think of one, like a half inch. So that's 12.5 millimeters. So a half inch is the actual openings in the wire mesh of the sieve. So it's the particles that get retained or pass through that sieve. So the way how classification works overall in general is you have your number 4 sieve, and your number 4 sieve is your determining factor of what is rock and then what is coarse sand. So coarse sand is material that's going to pass the number 4 but is retained on your number 10 sieve. And I can't remember the size openings for a number 10 off the top of my head. I think it's 2 millimeter openings. I think each opening's 2 millimeters big, but don't hold me to that, because when it comes to the sieve sizes, I'm used to the U.S. standard, which is the numbered sieves. But anyways, so the number 200 sieve, the whole idea of the numbering system is it's how many openings per square inch. So for number 4, that means you have 4 openings per square inch on your wired sieve mesh, regardless of the size of your sieve. Because you can buy sieves any size. You can buy them in 8-inch diameter, 12-inch diameter. You can buy them in trays. You can buy sheets and rolls of this stuff, which is usually for big aggregate processing plants for like asphalt and concrete to get mixed designs and things together. So it's not about the matter of how big the sieve is, it's how big are the openings that are in the sieve is what matters the most, to determine your particle size. So then you have a number 200, and that follows the same principle as a U.S. numbering system. So this indicates that there are 200 openings per square inch. So that's really, really small. That's really, really small size. This is technically, I think each opening is 75 microns big. Is what each of these openings on this sieve is for. Where pretty much your number 200 sieve is what retains all of your sand and aggregate and everything, and what passes through is your silts and clays, your finer material than that, which it's usually that material is what makes it plastic, is where you do your Atterberg limits and things like that. So it's that stuff that is surrounding the sand and stuff is what makes it plastic and whatnot. But so if we want to classify this, at least in general right now, which I can technically do because I do have that data, but I'm really trying to save this for another video, because as you can see, this is already running super long, which I knew these were going to be long. Don't get me wrong. I knew these were going to be super freaking long. But, so, technically this material didn't have anything retained on the number 4. So if this system works the way how I think it works, sieve percentages, Oh, wait. No. Let's read here. So percent greater than the 3-inch, 0. And then what is your percent that is less than the number 4? So actually, I think this should be 100%. Whoops. God, I hate. So we'll say 100% because I think it wants to know percent passing. And then what's your percent passing? Your number 200. Oh, good Lord. I'm just going to make up a number because I don't have that calculated because it's all a sieve and I don't have my thing. Yeah, let's just quit real quick. Hold on, let's do it the right way so people don't think I'm going crazy. All right, so let's see here. Yeah, because technically I did a sieve analysis for this. So if we have 149.31 minus, let's minus our tare weight. That would be 50.76. So this is our material of soil that's been air dried before. Let's just put that in memory real quick. All right, so if this is, so 9.01 divided by that times 100 minus 100. Okay, so we have like 90.9% passing. Oh, cool. Remembered that too. That's good. Okay, so let's do 90.9. Let's do that. So AASHTO or unified, so 90.9. And then I think it's going to, boom, classify it right off the bat. CL lean clay, which makes sense because that's what I was getting about. But technically this is AASHTO. But the thing for the AASHTO classification, it follows pretty much the same thing here. So we can quit that. So we already know it's CL lean clay is the group on how it's classifying. But if we, god dang it, AASHTO please. So technically for AASHTO, it's okay, what's greater than your 3-inch? And then this one you really have to do a sieve analysis on, to be honest. I mean, you really only need these 3 control points, your number 10, your number 47, and your number 200 to classify it, as well as is it highly organic-y soil, which classifies it if it has peat or not, which for that you have to do organic content. And Geosystems doesn't calculate organic contents. I think even the newer versions still can't calculate organic content. But, I think technically we're still running like version 5, which is kind of old. Because I think they're at 6 or 7. Something like that. I don't know. But, do that and then, there's your AASHTO. So this is giving a general AASHTO classification saying it's A76 is how they call that. Some people say A-7-6, but usually people just say it how it is. It's a A76. But for the AASHTO one, that will definitely be filled out once when we get our sieve analysis in there, which, all I really wanted to do for this video was to install the program, see if the program works, which ding ding ding, this is great, the program works. So I'm happy about it because I've never used this version of Geosystems before. I've used Geosystem for quite a long while, but I never used any of the older version stuff because we just always had the newer stuff. But it still kind of follows the same premise of even what the newer versions are, which kind of makes sense because if it ain't broken, why fix it? Just better up the graphical UI and everything and whatnot. But this is kind of cool though, because even for this gives you a rundown of your sample when you select it. Hey, what's been calculated so far? I mean, don't get me wrong. The newer one can do that, but it just shoots out reports separately. So this is kind of nice how you get a whole, a general rundown on, okay, so if for boring, well, for sample B1 at this elevation, hey, look, it's a CL. For the unified, right now it's classified as AASHTO A76. And here's our grain size distribution's been determined with these 2 points so far, even though technically we can do a regular grain size distribution. And then, hey, here's our Atterberg limits. Now, I never used the Bundsmeyer classification sheet. You know what? I guess we'll check out the other ones. I don't really technically. We can do USDA classifications. It's not asked often. Hold on, let me take a drink of tea here. We can do them. Obviously, it's not hard because, as you can see, just like for any classification, it's just asking, hey, hey, what's your percent passing your number 10? What's your percent passing your number 270 sieve? Which technically we don't have that size sieve. And then, hey, what's your percent finer than 2 micron? That's what that weird, like, U-looking symbol means. That means micron. And then, of course, it's almost like a oh my god, I can't I can't think of the name of it. I mean, I know it's a triangle, duh, but like a radar graph. It's almost like a radar graph. So kind of like if you play a lot of RPGs and MMOs that have a bunch of class building and whatnot. It could be more here than there. That's kind of how this thing works. So if I just want to put some data in, I don't know, I'll say 99.9. I don't have a 270 sieve. Ins percent passing. Oh, good lord. I don't know. Let's say 95.5 and 2 micron. What's 2 micron? I don't even know what 2 micron is. Good lord. That's what is that? A number like 400 something sieve? Oh, I don't know. Let's say 99.6. Okay, yeah, no, something's wrong. You don't have negative numbers. On the number 10 sample portion. So actually, would I need a 250 in there? God, I hate how that works. Yeah, it didn't really do nothing. What if I said export class? Place the edit cursor at the point where the insertion should be made, then click the continue button. What does edit do? Paste and underline. Okay, I don't care. Anyways, okay, yeah, so it's USDA. So the Burmester class, I've never had anybody ask for this at all. Like, I know we can do it. It's no better than the USDA, but it's either AASHTO or Unified is what we deal with the most for when it comes to soil classifications. But as you can see, it's just all based on, hey, what were your particle sizes? What was, what kind of components. Oh, that just exports whatever that you have in your thing. Which, I mean, technically we could do almost all these, at least for the sample that I have, except for this 0.02 millimeter sieve. We don't have that. Well, actually, no. Hold on. Let me rephrase that. Technically, you wouldn't need a sieve for that. You could do a hydrometer to figure out that particle size. But I mean, for the sample that I have, I don't have that. I don't have a hydrometer. So I know I can find a hydrometer test and pull that and then use that and whatnot. But you know. All right, yeah. So grain sizes, like I said, I don't want to cover into that. I really just only wanted to cover Atterbergs, but obviously, me installing all these other components and stuff kind of ruined everything. But I'm kind of happy how everything turned out. This wasn't too bad. Could be worse. But I'm wondering, can we get a report out of this thing, or is this going to be, well, there's client info, well, we'll say LAS, let's say LAS.network improvements, and Dragon 1, there's project number, perfect. Now we got our project information. I'm wondering if we can actually do a report. Ooh. Can I preview? No tests have been selected for okay. That kind of makes sense. I don't have a figure number. Okay, how about that? Hey, there we go. Can I preview now? Hey, there we go. Wow, yeah, this report format is... I mean, this part's... Well, I mean, it don't matter what you get. This part's the same for classifying where your Atterberg would be at. So, kind of like how it's a CL. Well, as you can see, you got CL or OL, and the whole idea for... The OL and the OH just indicates if it has organics, is the whole thing. So you have to do an organic content. This by default isn't going to say OL or OH, but you can always change your classification though. You can always manually change the classification. So if we had organic-y soils, that's usually soils that are, and don't hold me to this because everybody's a bit different when it comes to organic contents, but organic-y soils is like 25% and greater. If it's over 50%, you're almost sort of hitting the peat territory, but really you could just have highly organic-y soils. I mean, what really makes it peat is, you got like greater than 75% for your organic content. That's your guaranteed. Yeah, you got a messy situation on your hands there. Okay, cool. Yeah, that's the report. So I guess you gotta select every individual thing, which I guess makes sense because that's something that would drive me insane. Like for how it's done currently. Data summary export. Oh wow, interesting. I'm just kind of messing around right now. That's all I'm really doing. Just seeing. Don't really care. Never had that envelope printing. That's pretty cool. Source sample, sample source, liquid limits, basic liquid limit tests, and geoadapt. Oh wow. Got Corps of Engineers form and things like that. Wow, right out the box. That's pretty cool. You know, unified or ASHTO, however that you want it, and chart type plasticity or just moisture versus blows. Tear database. Yeah, I thought so. It's interesting how I wanted to import some. I wonder if there was something. Yeah, it don't matter. We'll do both. Applies only to projects created after time. Okay. Well, whatever. I guess it's too late for the LAS project. Okay, yeah, that's cool. Or LAS.network improvements, I'm sorry. It's weird that underlines an option, but I guess it was a whole new thing. I still can't believe it did that. That's interesting that it did that. All right, save and exit. Cool. All right, yeah, no, I think we'll end this here. You know, I'm pretty sure there's nobody here. Yeah, no, it ain't looking. It's not looking that way, which is okay. Yeah, we got nobody but me here, so yeah, but there you go, guys. That's our first intro for the topic video. Checking this out. I knew this was going to be a lot of me explaining things. You know, that's just kind of how that. You know, I mean, it's like I said. I don't know how many actual engineering students will run across this, or lab staff, or people, or whatever that will come across this. You know, as the years go on and whatnot. But you know, I mean, well, it's fun for me, and that's all that really matters at the end of the day. But yeah, you know, but I mean, I hope you enjoyed this and whatnot. It kind of gives a little bit of a background for what I do. I know it would be better to show what gets done in order to get to this point, but I mean, like, look, I'm not going to be doing all that. You know, I'm going to be very upfront. I don't see me doing anything like that. I don't really have video equipment to be doing anything like that too. All I have is my phone. I don't even have a webcam for my desktop. So, yeah, there's that. So, yeah. But anyways, hopefully you guys enjoyed this and whatnot, at least the video aspect. I am not surprised nobody joined. I mean, it's 5:41 in the morning my time. You know, this is a very off hour to be doing this, but that's kind of how my streams always go. You know, either I'm held up with other things or life or something, and then it's usually not till the weekend, till the end when I'm done with doing everything and taking care of everything else. But yeah. Anyways, this is where I'm going to end the video, everybody. So I'll catch you guys on the next one. See ya.